Hi everyone, myself Nithin Heraje, Assistant Professor, Department of Computer Science and Engineering, AJ Institute of Engineering and Technology, Mangaluru. In this video, I'm going to discuss about input and interaction, that is from Module 5 of Computer Graphics. Uh, uh, the input devices are classified into two, that is physical input devices and logical input devices. So if you look at physical input devices, you have keyboard devices and pointing devices. Whereas the logical input devices, just an example I can give is that in the C program we use a scanf function. So that acts like a logical input device. Uh, Looking at different pointing devices, we have mouse, trackball, we have data tablet, and light pen, joystick, space ball. Okay, so next is about positioning. So there are again two types of classification and positioning. One is the relative positioning, one is absolute positioning. So mouse, trackball or track point, these will have the relative positioning. That is, you place your mouse cursor. So it is having position Vx and Vy as per the mouse, and if you're checking with the screen coordinates, that would be X and Y. So which we call it as a relative positioning. Whereas you come to data tablet, where you have absolute positioning, that is in the touch screen you point out the exact location. So it gives it has only X and Y position there, nothing else. The logical input devices, there are two characteristics, that is one is the measurement, which is returned to the program as input, and the next is the time when these measurements are written. So it might be event might be occurring, or a time or whatever it is, when the measurement is written to the program. Okay, basically this logical input devices are classified into six categories. So first one is that the string, which is given by the keyboard, and next one is the locator. So locator, it is given by the mouse or the trackball. It gives the location. Okay, and a pick, so the id of the selected object is written, so you'll be having a n number of objects in the screen, so you can just go and click on a particular object wherein it returns the id of that particular object. Next you have is that choice. You can select any one option among the given different options in the menu. So that is across the choice. Then is the valuators. So valuators, I can give the example of boxes, which provide a value. Then is that the stroke, which returns an array of locations. So it could be implemented by mouse dragging. So whatever locations it selects, so it gives you those locations, which is called as a stroke. We have three different input modes. So there are measure and trigger. So let's see what is measure. Measure is that what it returns to the user program. For example, an value it might be, or whatever it returns to the user program. Trigger, it's a physical input to the signal, the computer. So trigger is some kind of action that is happening. For example, measure of the keyboard is a single or a set of character. Trigger is enter key. So what you do is you press a character, for example, hi, and then you press the enter key. So where hi would be the measure, and after pressing enter key, that is enter key would be the trigger. Okay, so after you press the trigger, that is the enter key, the value would be taken in the program. So input modes, first one is that request mode. There are three different input modes, out of which we'll discuss the first one, that is the request mode. The measure of the device is not returned to the program until the device is triggered. Okay, so you have this request locator device ID, and you can get the from which device it was triggered, and here is the measure or the value of whatever it was given as the input. So the program will request uh, for the measure. Okay, so soon some trigger is going to happen. When the trigger, then that measure is given to the program. So that's about the request mode. And second one is that the sample mode. So under input modes there are three. First one we saw is the request mode. Now the second one is the sample mode. Here if you look at this diagram, the program simply requests for the sample, and this simply gives you the measure. There is no trigger as such, no third party. So you basically, for this only one input device would be used. There won't be any multiple devices. Okay, so sample mode, the input is immediate, no trigger is needed. So that's what we observed in the diagram. Sample locator, again this will get the device ID and the measure, since it is having the same input device, so this would be same. And both request and sample modes are useful for the program where only one put device is used. Okay, so that's one of the main thing. Next is that input modes. So in the input mode, the third mode is that event mode. So in event mode, each time a device is triggered, an event is generated with the ID for the device, and measurement is put in an event queue. Okay, so what happens here is the thing starts from here. So each time when a device is triggered, okay, an event is generated, and the measure is stored in this event queue. So the program will be waiting for an event. So soon it receives a measure. When an event occurs, it returns the event to the program. So this is the event mode, which is the third of input modes. Next is the client and servers. So we know what clients and servers do. So clients will request for the service, and the server will provide the services to the clients. Okay, and one of the example is that OpenGL application programs would be the service. Next we have is the display list. So you can see a simple graphics architecture where you have a host which is displayed in the display or the monitor. So next one, the host, and we have these two things in addition, that is the display processor, and we have the display file. So display file will give the parameters to the display processor unit, which displays the objects on the screen or the display. We have immediate mode versus a retained mode for the display. So immediate mode, as soon as the program executes a statement for an object, the primitive sent to the display and no memory is retained for the object. So soon after you execute, the object will be displayed on the screen, and whatever those primitives will not be saved for further display things. Whereas in the retained mode, it defines an object once and put its description in the display list in the server, okay, which is retained there, and client issues a function call to the server. So whenever the clients want to display a particular object, it just issues a function call, okay, again and again. The construction will not happen. Just with the function call, everything goes smooth because already it is the retained there. Next is raster text versus stroke text. So raster text, which has the fixed size for each character, and that is not good for scaling or rotation. You can see this input output, so which is an example for raster text. Next we have is that stroke text. If you look at these two diagrams, so this is example for stroke text. So here it does not have any fixed size, and it could store the patterns in ROM. Selection is based on a single byte. So it's this is basically good for scaling or rotation. You can increase and decrease the size, and you can rotate these objects. So these are fine, goes fine with the scaling and rotation. Next is programming event driven input. So whenever an event occurs, some task has to be performed. So that is basically done using the pointing device. First event is that a move event. So mouse is moved and one of the button pressed. So this is an example. When mouse is moved and one of the button is pressed, it generates some event. Next is passive move event, where just you move the mouse, then the event is generated. You don't have to press any button. The third one is that a mouse event. So one of the mouse button is pressed or released, it generates a event. Okay, so pressing would be one event, and releasing the mouse button would be another event. So for this, first you want is to register the mouse function. So glut mouse function you need to register, and this name can be anything. So here whatever you are using in the function name, so here you are using as mouse, so we are using the same thing. Int button, which says either left or right, and state if it is down or up, if the mouse button is up or down, that is released or pressed. Okay, and then you have x and y parameters. The other events are you can just see the reshape event. Whenever the window is resized, okay, then you are supposed to use glut reshape function, and this is my reshape, which specifies what has to be done when a window is reshaped. Okay, next we have is the keyboard event. So again you need to register this function, that is glut keyboard function. Need to register the keyboard function, and your passing keyboard is the function name. So void keyboard, unsigned char key, x and y position. So whenever you press a key, so that key, if the pressed key is lowercase q or uppercase q, then you need to exit. So that is what this keyboard function does. Next is a display and idle callbacks. So glut display display function normally we use whenever we want to display object on the screen. Next is glut post redisplay. This ensures the display will drawn at most once in the main loop. That means if you call this function, the objects will be continuously displayed in the screen. Next is the idle callback, which is invoked when there is no other event. Say suppose you are involving some events, that you are using some mouse events. Then when you click on some event, so that particular event will be happening. So after that you are not going to click any, you are not going to use the mouse. So what happens? It is in the idle mode. So what it will do when it is in the idle mode, whatever already you have done, so that task would be taken place. Or you can also give some other inputs as idle. Whenever the things are idle, so it can be, you can have any blank screen or whatever you want to have, or you can repeat whatever the things that happened in the last event. Next is that callback could be changed at any time or disabled by setting it to null. Okay, so this can be disabled also. Next, coming to the window management, so we can have multiple windows over here. So this is glut create window is the function that we are going to use to create the window, and this is the name given to the window. So each window we are generating, it generates a ID for each window. So that ID is stored here. Okay. Next is glut set window ID. This is used to mention which window should be the current window, because if you are creating many windows, then you have to set any one window as the current window at any point of given time. So then you can go for set window, okay, by passing its ID. uh, then you're calling glut init display mode before uh, you are going to create the window to set the attributes. Okay, you have to say the mode of the display mode. Okay, so which will initialize all the attributes. Next, going to the menus, we have pop-up menus. For pop-up menus, we have these codes. Okay, glut create menu. You have to register the callback function, that is to create a menu, and this would be the demo menu, would be the function that we are going to use to specify what action has to be taken place when a particular option is selected. These are the, you are going to add the entries. So quit with the ID 1, and increase square size. This is the option that is displayed, and this would be the ID for that. Similarly for this. Okay, and here glut attach menu. So glut underscore right underscore button. So this says that when you click on the right mouse button, this particular menu will be attached or displayed, and what you select, either 1, 2 or 3, based on that these operations would be taking place. Okay, if it is 1, you have to exit. If it is 2, you are going to increase the square size, so size equal to 2 into size, that is your doubling. Here you are reducing it by 2, the size has been reduced it by 2, so decrease the square size. Okay, reducing by 2, and then again you redisplay the object, the reconstructed object, I mean. Okay, you can also have hierarchical menus. You can see this is one menu, and this is the sub menu that is attached to resize. Okay, so here glut create menu, the size of the menu. So sub menu, it holds the ID of this menu. So sub menu will hold the ID of the menu created here. Okay, then you will add the choices or the options for this size menu over here, or the sub menu over here. So increase square size and decrease square size 2 and 3, and you are going to create one more menu called the top menu. So under that you have two options adding. One is that quit with ID 1. Second one, here you have to concentrate. So this gives you the name, that is a resize. This name is given here, resize, and this is a sub menu. This is nothing but the parameter, that is this. already you have one more menu, so that parameter is this. So when you just come over this resize option, you will get other two options. Okay, so this is how you can, again, here you have a attach menu. When you have going to click right button of the mouse, this menu will be attached. Okay. Next concept is rubber banding. So just let us go through this. So rubber banding is a technique used to define the elastic nature of a pointing device to draw primitives. So rubber banding begin when mouse button is pressed and continue until button is released. At that time, final line segment is drawn. So you can just look at this. If you are going to draw a curve like this, or say you are going to draw a line segment, that is this line segment. So what you will do is you will press the button over here, and firstly you hold the mouse cursor over here, then you hold the mouse cursor here, here, and finally when you reach this point, you are going to release the mouse cursor. So when you sorry, the mouse button. Okay, when you release the mouse button, what happens? Line segment is drawn. So if you look at this, see, this is, if I just press the mouse button here and take it here, the line segment will come along with me. If I reduce it, it reduces this dotted line, so which acts like a rubber band. Okay, so that's what rubber banding means. Next is the logical operation. So you can look at this. So there's a source pixel and whatever read pixel, then you get the destination pixel. Okay, so you have copy or replacement mode. Copy mode in the sense you copy a primitive exactly to a different location. Replacement is already there is a primitive, you are going to make changes and draw some other primitives there. So that means it is a replacement mode. For example, say you have a black colored background screen. Okay, and what you do is you will draw a rectangle of a blue colored lines. Now what happens? The complete background was black, all the pixels were black. Now some of the pixels will turn to blue to form a rectangle. So there what happens is black to blue, it is a replacement. Okay, so that are the different operations for logical operation. And there are 16 possible operations that can be performed with between the two bits. Okay, we have source pixel and destination pixel. So source pixel, as I said, the black pixels which was there, and later on it turned into the blue pixel. So we call initial one as the source pixel and the blue one as the destination pixel. So next, coming to the XOR operation, see, you are going to XOR destination pixel and source pixel, and you are going to get a D dash. Now, if you XOR with the same, you will get the remaining one. That is, see, D XOR with S and XOR with S again, you will get back the D. Okay, that means drawing something twice will erase it. All right, got it. OpenGL support all 16 logic modes. So GL copy is the default basically, and GL enable color logic operation. So GL logic operation, it is XOR mode. You are changing the mode to the XOR mode. So you have 16 different logic modes, XOR, or so on. Okay, so out of those 16 logic operations, you have XOR and or all those things. Okay, out of that you can set whichever operation you want to perform for the colors. So here it is set as XOR operation. XOR and color. See, this is one color which is blue. So RGB, it is blue, and next one is all white, which is all ones, which is white. So XOR blue with white, you are going to get to this color, that is red and green you'll have 1, whereas this you get it as 0. So red and green 1, in the sense it is a yellow color. Okay, so if a blue line crosses a red object, it will be colored as magenta inside the object. So XOR blue and red, then you are going to get the magenta color. Next is picking, say this is in the world coordinate. You have the objects, okay, and this is the viewing screen over here, viewing window, and these are the objects. So these are the objects which are clipped over here. Now you want to select this object, or you are going to pick this. So whatever screen you are showing, only that thing has to be picked up. So in this there is a problem, because in our pipeline, so once from the world coordinates we have come to the screen coordinates. Here if you look at that, you need to go back to the world coordinate again, and then you select whatever area you want, or you pick the area that you want and then display it. So this is picking is quite complicated in this. So identify a user-defined object on the display. So in principle, it should be simple, because the mouse gives the position and we should be able to determine to which object a position corresponds to. But the practical difficulty is that the pipeline architecture is feed forward. It is not, go backward as such. And it is hard to go from screen back to the world coordinates. So complicated by screen being 2D and world is 3D. So this is one more complication. How close do we have to come to object to say we selected it? So that is one more problem, whether we are not sure if that object is picked or not. We do not know how close you need to go to pick that object. So that is one more practical difficulty in picking. If you want just a simple paint program, draw geometric primitives, that is to draw line segments, polygons, etc., and to manipulate pixels, control attributes of the primitives, and then include menus, and it should behave correctly when moved or resized. Okay, any primitives has been moved or resized, it should act properly. So this is to have a simple paint program. So for this also it is possible to write a program using computer graphics and achieve all these things. So the initial display of the paint program would be like this. Okay, so and the menu structure is like this. So when you click on the right button, you get these two options, quit or clear, and when you click on middle button, you get these three options, colors, pixel, and fill. And all these three will have submenu. So colors has this submenu, and pixel size has this submenu, fill has this submenu. So this how the first appearance of the program output. So there should be 5 drawing modes, so that is line, segment, rectangle, triangle, pixel, and text. And 2 to 3 clicks determine the locations of the endpoints of a line segment. So if it is a 2 clicks, then it would be a line segment, or it can be a triangle. If you want, it can be a rectangle. If you want a triangle, then you should go for 3 clicks. And you can choose the colors, pixel size, and you can use different fill patterns for these primitives. So this is an sample output of the a simple paint program, where you can see you've drawn a triangle here, you have drawn a pixel, you have a line segment, you have drawn a rectangle, and also you have drawn a text in the paint. Okay, So this is about input modes and interactive. Um, I hope you have understood this. Okay. Thanks for watching this video. If you like, please click on the like button. Thank you so much. Thanks for watching.